So this video is another response to a post on the Fusion 360 forum. The user has created this keycap and used some previous advice, but now he's getting these extra lines or edges and is wondering what's the cause for this. So those edges are called tangent edges. And I'm going to use a simpler loft to explain how those get there. Because this is a bit of an extreme case, then there's some middle ground, and then there's another extreme case. So I've created a simple object here. And let me hide the body real quick. I created two simple sketches with the slot tool in the sketch environment. Two arcs at the end, tangency conditions where the lines join with the arcs. I've done that twice. The low one is bigger, the upper one is smaller. And I then created a loft from that. And that looks okay, but we can see in the reflections here in the viewport that there is a pretty sharp transition from that sort of cylindrical section here to the straight section. And the reason for that sharp transition is tangency, right? If we take a look at the curvature cone analysis, we can see that the curvature of an arc is constant. It doesn't get any smaller here and fade into this line, but it's sharp. And that's why we see that rather sharp transition. So what Fusion tries to do when you create a loft with specific settings that are the default is merge tangent edges. And that means where it encounters tangency conditions, it just creates one contiguous NURB surface and wraps it all the way around until it comes to this point here where a loft has to, in Fusion 360 at least, the loft has an end and a beginning, and this is the seam where they are stitched together. So that in this case also coincides with one of the tangency lines. So if we take a look at the surface quality of such a surface with the Curvature Map Analysis tool, we can see that we get these artifacts here, and I've already set this to high quality. And we can alleviate that a little bit by changing that from display detail control here from adaptive, which is the default, to high, which I've already done. But this is about as good as we can get it in terms of how it looks like in the viewport. Now, would that make any difference in a 3D printed product? Probably not. 3D printing is way too coarse to highlight such issues. But if we're talking about trying to create ideal geometry and better geometry for continuing modeling purposes, then this isn't the way to go. So that is where the Keep Tangent Edges option comes in. It inserts additional edges and creates separate surfaces where it encounters a tangency condition. And we can already see that the geometry changes slightly, but also these surface imperfections where we encounter tangency are not there anymore. And we get what we would expect in this case. We get a sharp transition from that circular surface here into that straight surface. Straight, at least in this direction here, in the Y direction. So that's what tangency edges are. And we can see in this case, we get the options to turn them off and turn them on. So, okay. So that's sort of the middle ground. You can have a choice between the two. So let's go back to our keycap and let's take a look at that. I'll roll the timeline marker back here to right after the stitch operation. So we basically have our raw body that was then filleted. And let's take a look at it with the curvature map analysis. And that doesn't look so great, right? We have these very strange surface artifacts here. And if you go into the render environment and apply a glossy surface, they're also visible. Again, if you would see that in a 3D printed product, I don't know, but we're trying to create ideal surfaces. So we got these tangency lines, so how do we get those? The loft that creates this the surface is this one. So it lofts from a flat surface or from a flat profile to a profile that already has curvature, right? Here at the end. Those line segments are straight, but this is curved, this is curved, this is curved, and the same at the other side. And the odd thing that we can see here is that the option to keep tangency edges is actually not turned on. So there's a condition that requires Fusion's Loft tool to insert those anyway. It has to insert those in order to create a valid surface and solid body. So what is that condition? Right. In order to explain that, I have to scroll the timeline back and explain how this was created. So the user created the bottom profile here, and I have to go into the bodies and turn this back on. But this is a top circular surface or a cylindrical surface created by extruding from the original sketch here, this line here, this arc. And then he created two surfaces, made surface splits, threw away the sides, then created a construction plane along a path and created a sketch on it that I need to turn on so we can actually see it. And then he actually created a patch surface from that sketch. And then he did the same on the other side with a plane, and then figured out I can actually mirror this and mirror this over. And if we take a look at the bodies that we have, let me turn the sketches off so we can actually see this. We have three surfaces. We have edges along here, we have that edge, we have these edges here, and we have that edge. And what the user did then is he created a patch. And that looks nice at first sight, but if we take a look at how it reflects light, even already in the viewport, we can see that it looks a little bit more indented here and a little bit more indented here, so it's not straight. It's not as straight as these straight sides here would indicate that are created from the sketch. So if we use our Curvature Map Analysis tool, that confirms that as well, because otherwise it would be green here and it wouldn't be curved like this. Another tool that we can use to inspect the surface is the IsoCurve Analysis tool. And that shows us how the surface curves over its entire surface, and we can increase the density of curves and the scale and the density of the hairlines in the curves. But we can already see that it is sort of not very even. Here it's kind of wavy, and it also curves in this direction, which it actually shouldn't because there's a straight line defined here. And the reason for that is that the patch tool basically works like a cloth that you stretch over a thin rim. In this case, a rectangular rim, and you only have so much control by applying tension at the edges and sides of that tablecloth, but you have relatively little control over what the surface does. Now, you might be tempted to use internal rails, but I would advise against it. The patch tool is just not the right tool to create this sort of surface. So let me delete that curvature map analysis. For the moment, we don't need it. But the real culprit here is actually not the curvature, because that actually doesn't look too bad. It looks wavy, but it doesn't look unsmooth, if that's a word. Where the curvature breaks down is here at this edge. So remember how that edge came to be, right? That edge was created from these profile sketches, and that profile sketch, if we use the curvature, let me hide the construction plane, it's in the way. If we use the curvature comb here, we see that is super, right? That's exactly what we would expect from an arc. But if we hide that sketch again and take a look at the surface that supposedly was created from this arc, and it was, we see that the curvature comb here, oops, does not look good at all. And it's a good practice when you work with surfaces in Fusion 360 or generally lofts. Any loft that creates a curved surface, lofts and sweeps that create curved surfaces, you should always check the curvature. Use the curvature map analysis, use the iso curve analysis, and particularly on edges, use the curvature cone. And if it looks like this, you should not create further geometry from such an edge. And that's really the reason why the user gets these tangency lines. Fusion 360 does not have an option to not have these tangency lines, otherwise it couldn't create a valid surface. So knowing that now, how do we fix this? What is a better way to create this top surface? So first of all, because I'm really having a hard time with these new controls here. I don't find those very intuitive. I might just have to work with that for a little bit. So that profile that you created here, you could have easily swept it along this arc. Even better, probably, would have been a revolve. You would have had to create an additional axis here, so that's rather inconvenient. So in this case, I would have also used a sweep along an arc to create that surface. So I basically sort of redesigned your keycap here using fewer features and solid bodies, because in this case, you don't necessarily need to use surfaces. I would restrain the use of surfaces to those areas where it's really needed. So similar to your design or to this user's design, hopefully he's listening, I'm basically not using this sketch that provides me with some references. So we can hide this. I created the bottom profile and I created a flat, I extruded it, created an offset plane, and created the top profile. And that top profile is exactly the dimension that it's supposed to be. That sounds kind of silly, but I'll get to that in a moment. And then I loft. And the curvature map analysis is already turned on, and as we would expect, that is spiffy clean. There are no tangency edges because this is a straight line, right? So then I also created a plane along a path, similarly to what this user did in his design. Plane along path. This arc here is the path. Then I also created that same, well, almost the same profile. And I sweep that profile. Almost, because if I sweep that profile, I need to make this profile a little bit longer so it cleanly intersects this surface here. So I added 1 millimeter to that edge here. So it probably doesn't need to be 1 millimeter. So and then I sweep this. And that gives me a really clean surface, as we can see. So the next question is, of course, in this design, the user lofted to this curved surface. So if I would now also, instead of using a loft to a flat sketch, if I would also loft to the surface, would I get these tangency edges? Let's see. Let's go ahead and just delete these surfaces. And create another loft. Chain selection is turned on. This profile to this profile. And let me turn on tangency. And well, I have that option enabled. So I do get the tangency edges. And let's take a look at the analysis. Let's look at our curvature map. So that doesn't look too brilliant with the tangency edges enabled. It doesn't look as terrible as the first time. And let's disable the tangency edges. That actually doesn't look too bad. And in this case, we actually get the option. So There's another case where you can click on tangency edges or on merge, where you don't get any tangency edges and get a super clean surface. So what is that condition? So let's go back to the sketch here and take a look at this sketch. The reason why you get a tangency condition in this case that I just demonstrated is because you have tangency defined here, right? So let's delete these arcs. And put a fit point spline there. And a fit point spline, come on. And a fit, and a fit point spline there. I would consider that Fusion 360 hiccup when I cannot select that endpoint there. So without further ado, finish sketch, and we can see there's no sharp transition anymore. There is a bleed out or fade in, however you want to call it. And now we can try to loft this again. All right, so we can already see I still have that choice between tangency edges on and off, and it doesn't really matter whether or not I select this, set this to tangency. I can turn them off and on. So the reason for that is these are still 3 separate surfaces, right? Because I have a defined border here, so to speak. I have 3 separate curves in my sketch. So let's edit that sketch again. And I copy that dimension because I need it later, and delete this line, delete this, and I also don't need to see the construction plane. I don't need this anymore. I'll leave this. So I'm going to create a simple control point spline, a 3-degree control point spline. That means it has 4 control points. And I'm going to constrain that the center of that construction line here to the center of my sketch origin. I turn on my curvature comb. Come on. And obviously that changes as I pull these control points out. So obviously that doesn't give you a perfectly straight line, but it only has very gentle curvature. So what I'm going to do now is turn the body off for a moment. I insert a point here into the curve right there. That's my center point. And then I dimension from that center point on the curve to this line here and insert that dimension that I copied earlier. So now I have that exact depth defined. So let's finish that sketch. And if you take a look at this now, this is super smooth and it's a single surface. So if we loft now, even to this curved surface, or this surface with all curved edges, and I'll set this to tangency, I can, and that's the other extreme case, when Fusion has no reason and no way to insert tangency edges anywhere. So that's the other case where you get no tangency edges whatsoever.